Welcome to Clojure at DataStax, the long road from Python to Clojure. Thanks to Paula and Stu for starting the day off. Hope everyone's college is going well so far and everyone's travel went well. I'm glad my talk is early on the first day, so I get to stop worrying about it and enjoy everyone else's talk the rest of the time. So a little overview of what we're going to be talking about today. As usual, we'll start with an introduction, but we'll move on into how DataStax started, specifically the product I work on, and how we started with Python and why we started with Python, and then why we decided to bring Clojure into the mix and why we're continuing that journey of moving from Python to Clojure. So a little bit of an introduction about me. I work at DataStax. Specifically on our OpsCenter product. I'm a big fan of Clojure, been using it for 6 years now. If you don't know anything about DataStax, we're heavily involved with Apache Cassandra, and I run the Austin Cassandra meetup. And I'm from Austin, so if you have any desire to talk about any of those topics throughout the rest of the conch, come find me and we'll chat. A little bit about DataStax. We develop a database we call DataStax Enterprise, or DSE for short. It's built on top of Apache Cassandra and combines other things like Spark, graph technologies, and search. OpsCenter, which is the product we're going to be talking about today, is a monitoring and management tool for DataStax Enterprise. And it is built with Python and Clojure, which is the topic of today's discussion. The other thing to keep in mind is that both DSE and OpsCenter are shipped software, not hosted software. So, things we're shipping out to customers and letting them run in their own infrastructure. So this talk is kind of our experience. It's an experience report with Cassandra, or with Clojure. So it's not super low level. There won't be a whole lot of code examples or things like that. But more of a high level of how Clojure has been for us, how we've migrated away from Python onto it, and what the future holds. This should be especially interesting if you are a Python shop and you're interested in Clojure, if you are have a Python application that you would like to maybe move to the JVM. So starting from the beginning. A long time ago in a galaxy far, far away, which is actually not true. It's actually a long time ago in an office not far away. The DataStax office is about 5 blocks from here. Could probably get there and back before the end of this talk if I wanted to. But we set out to build a database monitoring tool. And so DataStax as a company was just founded, brand new company. Built kind of around Apache Cassandra, and we're building a monitoring tool for it. So I don't know how familiar the room is with Apache Cassandra or distributed databases. This is a typical diagram you would see of a Cassandra cluster or a DSE cluster. It's a scalable database built to scale from 4 nodes in this example to thousands of nodes. Typically, you'll see it modeled as a ring like you do here. And so the first step we took in building a tool for monitoring this database is we built a web server. So this is going to be a web application for monitoring it, and specifically we built it on Twisted Python. That's the logo for Twisted Python, so in case you weren't aware. And so that's responsible for talking to the database, serving up visualizations, monitoring and data and things like that. You might think to yourselves, okay, but why? Why would you pick Twisted? Clojure exists. It's out there in the world. You could have picked that. Today I would agree with you, but this was 5 years ago, like we mentioned. So this is 2010. DataStax is a 10-person company at the most. The people working on this product in particular, there was one front-end developer, one back-end developer. And the back-end developer knew Twisted. So if you've ever been a part of a small startup, I think you probably already know that the most important thing is getting stuff out the door as fast as possible. So Twisted was kind of the logical choice from that standpoint. So we have that. That's great, but product complexity grows. You need new features. As with any monitoring application, it's quickly discovered that you need some sort of agent to run on the things that you're monitoring. So logically, the next step would be developing an agent. We already have Twisted Python. Let's write it in Twisted Python. That's what we know. That's the next step. And that's where things start to go wrong. And the reason being, the JVM, it doesn't really play nice outside of the JVM. I don't know if anybody here has ever tried to monitor and interact with a JVM application from something like Python, but it doesn't work really well. Java has this thing called the Java management extensions that make it super easy to expose operations and information, but only to expose those to other JVM applications. Anyone else is kind of just out of luck. So that's not working, and that's where Clojure enters the ring. I set up that ring metaphor earlier just to land this pun. But keeping in mind, this is still 5 years ago, right? So we quickly knocked out this Twisted agent, and even quicker realized that it wasn't going to work for us, and we needed something else. So what are the responsibilities of this agent? Well, it's actually extremely limited in scope at the moment, right? It just collects some metrics, and it sends them back to our Twisted process that's running, and that's literally all its purpose in life. So what are the other requirements outside of that limited scope of responsibilities? Well, it needs to interact with the JVM, which we've, at this point, already established means it needs to run on the JVM. And the other two really requirements we had were it needs to be maintainable and it needs to keep the developers happy. So that kind of leads into our list of contenders. All of these are on the JVM. I'm fairly certain most of you have an idea of which one we picked. Java was, at the time, kind of the lead contender, really, because we were monitoring a database that was already written in Java, so we had Java experts. And the main reason we didn't go with that was developer happiness, right? So we had a development team, we're used to working with Python and liking Python, and not really super excited about the prospect of writing Java. So there was a list. Clojure won. The simplest reason was it was the one the developers enjoyed the most. So the others were kind of experimented with, but it was the one that was enjoyed the most. And this is such an isolated piece of the architecture that the one we landed on wasn't super important at the time, right? So all of them could interop with the JVM in the way that we needed. We liked Clojure. If it, for some reason, turned out not to work, pivoting and moving to picking something else wasn't, a huge deal at the time. So now we've got this new architecture. We're running Clojure. 4 years pass, and we get the results of our experiment. And the results are that it is a great success. We picked this isolated piece of our project to run Clojure. It fit all of our needs, and it continued to fit our needs as the project expanded. It turned out to be just a fantastic recruitment tool. And I'm sure, as you can see by this giant conference, Clojure inspires a lot of passion. And even by the people that, we didn't recruit specifically to work on Clojure, they picked it up and ran with it quickly. I want to give you a quote from someone on our team regarding learning Clojure, just to kind of emphasize really, I think, the passion that Clojure inspires in some people. So this is a quote by a guy on my team named Philip Doctor. He runs the Chicago Clojure meetup, so if anybody's from Chicago or passes through there and gets a chance to go to the Chicago Clojure meetup, I highly recommend it. And then one more note on hiring. I mentioned that Clojure was, a great, recruitment tool and turned out to be the right choice for those reasons. I think specifically in our case that, this may or may not apply to you, but DataStax is a distributed engineering organization. So, we hire people, and let them work from wherever they're currently located. So right now, we have engineers working on Clojure who are located anywhere from Hawaii to France. So that was one key thing. I think I'm not sure if we would have experienced that if we had had an office-based culture where we required people to relocate. So take that with a grain of salt depending on your specific situation. Just a couple of the rough edges. Clojure worked out great. There was a few rough edges, at least slightly worth pointing out. This was 2010, like I mentioned. At the time, we were deployed on 1.2 and immediately hit the pain of migrating to 1.3 and dealing with the explosion of the Clojure contrib jar. I'm not sure how many people were around with and had to deal with that, but it was a giant pain. At the time, when we were still a little unsure on Clojure, it was a kind of a warning sign. And the other thing we noticed was that there was, the JMX library, which is kind of specifically what we picked to, why we picked Clojure, right, to interact with other JVMs, was unmaintained, but the solution to that was simple. I just became the maintainer. It gets about one patch a year, so the workload is fairly low. And then at the time, this is kind of a problem that was only revealed in hindsight. The libraries back then were far less mature than they are today. Like as Stu was just mentioning, Core Async wasn't a thing back then. There was no component or mount or any of these libraries to kind of help you while you're building a Clojure application. So earlier, if you were asking yourself, why did you pick Twisted? Now you might be asking yourself, okay, you had an application with two pieces written in Twisted, and you decided to rewrite one of them. Why didn't you just rewrite the whole thing? Well, I think that's a valid question, and I, wish we had done that 5 years ago. But hindsight's 20/20, right? So while we were rewriting this small piece of our application, we were still a tiny startup and full speed ahead on everything else. So at the time, it seemed reasonable. With the benefit of historical perspective, something we wish we had done. So that brings us to DataStax's continuing march towards Clojure, back to the future-ish. So that brings us up to maybe 1 year ago or so. So what's changed from 4 years ago? Or 5 years ago? What's changed in that past 4 years? So like I said, Clojure was a great recruitment tool. The team has grown, starting from 2 developers to a team of 20 or so developers with multiple layers of management and all those types of things. Our Clojure code base itself has grown by leaps and bounds, right? So we've moved from an agent that is responsible for simply collecting and reporting, monitoring data to an agent that is responsible for taking backups and doing restores and provisioning and configuration and a whole host of other things, right? So while we initially envisioned some tiny piece of Clojure that we could run and rewrite at a moment's notice if we needed, we've now got this large application that is serving many different needs. Beyond that, DataStax as a company has grown, and the JVM has become somewhat of a standard across most of DataStax products, with the exception of the one we work on that still incorporates Python for a large piece of it. And just, I'm sure anyone here who has been working with Clojure for a while has noticed, as you work with Clojure, your love of other languages kind of fades. So we didn't necessarily dislike Python, but if we had a favorite child, Clojure would be it on the OpsCenter team. So the time comes and we need to kind of reevaluate the big center, monolithic piece of our application. So we reevaluated our agents and put them in Clojure. Now it's time to reevaluate the daemon piece. And so that was driven not just by a love of Clojure, but also by actual business concerns on our end. So as we've grown from a two-person team to DataStax being a 500-person company, the scalability requirements of our product in general have grown from typical sizes of 5-node clusters to thousands of nodes in a cluster. And so the needs of OpsCenter as an application kind of have changed in that. And kind of an artifact of that is we started running into kind of the limitations you'll run into with Python, specifically with a single process, right? So CPU usage became a significant problem for a lot of our customers. And even beyond just those problems, we started noticing that having an agent that is expanding in its responsibilities, as well as this central Python piece expanding, they started to overlap a lot more than we initially planned on in our initial evaluation, right? So whereas before they had distinct roles and responsibilities, now we're pulling in things like a Java library on the agent for interacting with Amazon S3 and the Python equivalent in the daemon, because they both need to have that interaction. So now you're learning two different libraries, pulling in multiple things, and so you're kind of generating a lot of overhead by having multiple languages in your stack. So the result of the reevaluation was that as a company we wanted to move towards the JVM. Specifically, on our team, we wanted to move towards Clojure, and we needed to address the immediate kind of scalability concerns we had with our product. So there's lots of ways to approach that problem. These were the ones that we considered. Obviously, you can stop and do a rewrite, which is what we did for the agent in 2010. You can switch to multiple processes and kind of slowly pull pieces out of Python and into something on the JVM, hopefully Clojure. And then there was this third idea, which we kind of came up with, which at first kind of was almost dismissed out of hand, but after some thought, we decided to at least look into it a little bit more. So the rewrite completely option has the benefit of letting you design an application with 5 years of historical perspective, right? And so you can kind of upfront avoid a lot of the mistakes you have made along the way while you were in startup mode and cranking things out as fast as you possibly could. But on the other hand, that's 5 years of code that needs to be rewritten. It's at least a 1 or more year pause in new feature development. And inevitably, you're going to introduce new bugs or bugs you've already fixed when you take a large application like that and just rewrite it. So it's one option. It has some downsides. The option to split into multiple processes avoids the problems you have with a large rewrite in terms of kind of time intensiveness or introducing a lot of bugs at once. But multiprocessing, specifically in Python, is difficult. And I don't know how many people have dealt with Twisted before, but Twisted itself is it's an event-driven language, and it's very interdependent. So pulling things out of a Twisted application, just kind of piecemeal and trying to put them into another application is not as simple as it might sound. It would almost essentially be somewhat of a rewrite in itself. And then you bring on the complexity of doing things like adding IPC. And keep in mind, this again is a product we're shipping to customers. So every process we add to this this software is additional burden on the customer in running and maintaining that process and keeping things up. So the last option, port to Jython. So this option, is theoretically completely behind the scenes, right? You could ship this application and customers could, in theory, not even know that it has happened. It also has the benefit of getting you on the JVM in the shortest path, although not necessarily using Clojure. But on the downside column, you see that out-of-the-box support for Twisted with Jython was not a thing. I mean, we knew specifically that it did not work. You're essentially introducing a third language. Jython is, a Python like language, but it's different enough that you'll have problems. And as far as I know, literally no one else has done this, right? So it's kind of, the road less traveled sounds very poetic, but it's not necessarily the thing you want to be doing while you're developing software. So without too much suspense, basically we took the Jython path, right? So, and the reasons we did were we decided it was the benefits of being immediately on the JVM and doing it in a way that was some under the hood somewhat in terms of customer impact were at least worth exploring. So we did a proof of concept, discovered that the time it took to get Twisted to at least run on the JVM was about a week, which wasn't unreasonable. And from there, it was worth the investment to slowly fix all the things that we broke while getting Twisted to run on the JVM. So that's the approach we took. This is what our application looks like today, right? If you go download it right now. But if you notice, I skipped the 1 year phase in between there. So let's talk about that a little bit. So these are the 4 easy steps for migrating your application to Jython. It's 4 steps. How hard could it be, right? So step 1, make Twisted run on Jython. This is the step that sounds harder than it is. Really, it just boils down to getting a stack trace, fixing it, rinse and repeat. And it actually happens that with the release of Jython at the time, which had just been released, the only problems that really existed were some decorators that Jython didn't understand and some references to Python's operating system libraries that we weren't even using. So a little bit of hacking there got things up and running. The next step is the most time intensive by far. Well, I guess it depends on your application, but any Python library that uses a C extension is just not going to run on Jython for obvious reasons. And there's a lot of them, so, and very common ones like PyOpenSSL. And so, in our case, replacing PyOpenSSL, PyLDAP, the Python SQLite library, PyCrypto, all of these things need to be replaced with the Java alternative. So, that takes time. Depending on, your application, it can be more or less time. And then the other thing we ran into is that Jython does not implement the sub-processing modules that Python has. So anything there needs to be also ported to the Java equivalent. Step 3 is the least fun of all of the steps of migrating yourselves to Jython. If I had to compile a list of the bugs that developers' nightmares are made of, this would probably be the list. So in the process of making things run on Jython, these are some of the highlights, at least, of the bugs we found in Jython. We filed maybe 15 or so bugs, but these are some of the good ones. So debugging deadlocks and GC deadlocks and socket leaks and all that stuff is not exactly easy and or fun. But we made it through. Actually do want to mention that this is not a criticism of Jython itself. The developers there were extremely helpful and willing to help us work through these problems. A lot of these were based on the fact that we were running on Twisted, which they never told us to do. We just decided to do, and they probably would have told us we would have run into these bugs. But we fixed them. One note, if I've seen lots of complaints about these, and if you thought stack traces and heap dumps were bad in Clojure, wait till you're running Clojure on top of Jython, and you'll really get the full experience. You'll enjoy your heap dumps from Clojure after that. So once you make it through that, then comes the fun part, right? So you can have Clojure running and you can have Jython running, and they can be running on the same JVM. But once they start trying to talk to each other, they get all confused. So Clojure doesn't know what the hell a pi function is. Jython doesn't know what an I-persistent vector is. Everyone's mad. But luckily, everyone speaks Java, right? So I put a link there. I didn't include the actual code, but there's a link to our translation layer. It's just a single Clojure file that puts everything in a Java format before sending it between Clojure or Python. So go check that out. So this is where we are. It's, I think an apt word to describe it would be Frankenstein-y. It's certainly not pretty or elegant, but it works, right? And so, in terms of whether or not I would declare our path to Clojure via Jython a success or not, I would say for us, there was some bumps. It took way, way longer than we thought it would. But in the end, it was the right choice. If we had to go back and make the same decision again, I would pick the same thing. So that's our present. Our future hopefully lies in the glorious land of Clojure and looking something like this. So the takeaways for this talk, should you use Clojure? As Phil would say, open yourself to truth and beauty. You should absolutely use Clojure. Should I not use Python? Well, no one said that. But if you are doing anything that is interacting with other JVMs, then probably not. I would say you should not use Python. Should I migrate my Python app to Clojure via Jython? Well, maybe. Do you really need to do that, or does it just sound kind of fun? Because if it sounds kind of fun, I'm not going to recommend it. Plus, I already got the conj so you're not going to even get that out of it. So the other thing to consider is, what Python app are you migrating, right? So if you're doing scientific programming with NumPy and SciPy, those are essentially all C and are never going to run on Jython and don't have a Java equivalent. So I would be an exercise in futility to try and run those on Jython. And I can't guarantee that in this process, the DataStax team has discovered all of the hairy deadlocks and socket leaks and just generally bad things that exist out there. So if you're not, brave and willing to venture into Jython land itself, I'm not sure I would recommend it. So that's the talk. I've got, I think, 5 minutes or so for questions, if there are any.